Okay, so we did a unit on space. We titled it To Space and Beyond, and it's our sixth grade unit, so it specifically meets the sixth grade standards. The resources are there. They were in the chat so that you can print them up if you want to do that, or you can just look at them because we will be referring to them. Please disable your microphone. You can still talk to us because the chat box is being monitored and we're happy to answer any questions. This is really to help you. We want you to be able to use this in your classroom, and we want it to be as easy for you as possible because we know as teachers there's a lot of demands for your time. So our norms are please ask questions, embrace mistakes, ours as well as yours. This is all new with technology, and we'll see how this works. We're trying to give you the new information. Please open your mind, ask us any questions you have, and then we hope that you utilize what you learn in your classrooms because ultimately that's how we help children. And we're hoping that what you get out of this is that you'll learn the format of Tool 4 that we used, as well as all of the other teams that developed curriculum, that you will understand the 5E lesson plan and how that works, and then also that you will have an overview of our Earth and Space unit. For the presentation today, we're going to be doing the first lesson, which is on moon phases, and there's 5 lessons in our Earth and Space unit, but they all follow the same format. So once you have this format, you should be able to easily look at the other lessons and figure it out. Okay, so there's our objectives. Again, reviewing format of Tool 4 so you know what it looks like, reviewing the 5E lesson plan, and then we're giving you an overview of our first lesson. So when you open Tool 4, this is what you see. Our unit name is there. Can you see my cursor on there, my big giant arrow?
Yeah.
Okay. So if you look, when in the new science units, there's the core ideas of what we want to actually teach the children, the science and engineering practices, which in our units are blue, and then the cross-cutting concepts, which if you look over here, we've done those in green. And those are super important because we don't just want kids to regurgitate information anymore. We want them to be able to actually use the practices that they would use, that real scientists use, so that as they're investigating units and concepts, that they understand them and that they're actually doing what scientists do in learning. So in our first one on moon phases, the students are going to be developing and using models. If you're a sixth grade teacher, as you look at these standards, you'll notice that we do a lot of developing and using models because our students are being introduced to these concepts as the introduction to middle school. So we do a lot of that. And specifically on our cross-cutting concepts, we're looking at patterns and cause and effect because we want the children to notice those things as they're doing moon phases. So up here you will see science and engineering practices and what they are for each unit, as well as the cross-cutting concepts, and then the core idea is here in the middle. The standard is actually right here. The solar system consists of the sun and a collection of objects. You'll notice that we're supposed to do planets, their moons, and asteroids. We cross those out because this particular one is only focusing on moons. And then so we crossed out the parts that don't apply to this one so that you can really hone in quickly on what we're supposed to be doing with the core ideas. So moving down, we've also included what the prior knowledge is. This is going to be a little tricky these first few years. If you look here for moon phases, you can see in kindergarten that they learned about the patterns of motion of the sun, moon, and stars. And then in first grade, they learned a little bit about placing objects with different materials in the path of the beam of light. You can see what they learned in second and what they learned in fifth, building up to what we're going to teach them in sixth. The problem is these are new standards. And so you have no idea what has been taught at this point in kindergarten, first, second, and fifth. So as they come to you, they may or may not have this knowledge at this point. So you need to be really careful, particularly these first few years, that you actually figure out what the kids know before you start teaching, because they may not have the foundational knowledge that we're assuming that they have. And as more of us teach the standards, then they will have that foundation later. And then if you look down here, we have common student ideas. Those are the misconceptions that a lot of kids have about moon phases. And it's really important that you read through those before you teach each unit, because you're going to see a lot of these misconceptions with your kids. And so we want we want you to be able to focus on those and get those out of the way and correct those misconceptions so they have the knowledge that they need. So they might think that the moon actually creates its own light, which isn't true. So you'll need to address that in the teaching. And you can just read through them. They think the moon's only in the sky when it's dark at night. A lot of sixth graders still have that conception because they haven't done a lot of study with it. And we want them to understand that the moon doesn't give its own light, that the moon is there all the time, whether it's dark or light. It's just we only see it often when it's dark. So just make sure you look through those misconceptions. And just so that you know, our unit's a little different because a lot of the other units put all of the resources at the top of their tool floor. We felt like not all teachers can do all 5 units, and not all teachers can do all 5 lessons because sometimes they only have like three times they can teach science during the week. So we actually put the resources at the front of each of the 5 steps so that you can look at those resources and figure out what you need for the lesson piece that you are doing, and it's right there and easily accessible. So that's kind of any tool floor that you open, that's what will be at the front, and that kind of explains what each portion of that is so that you can look and get an overview of the unit before you start teaching it to your students.
In addition to teaching the phenomena and teaching the 3 dimensions, we're supposed to also teach with the 5E lesson plan. So there's 5 parts to a 5E lesson plan. First is engage, where you're grabbing the student's attention, and then explore, where they are exploring the concept on their own and creating their own vocabulary. And then you explain, give them opportunities to create meaning from actual sources. And then elaborate is where they put it into their own, to a new situation, and then you evaluate them. Next slide. So here's the breakdown again of engage, explore, explain, elaborate, evaluate. Now there's an arrow between explore, explain, because sometimes it has 5 parts and sometimes it has 7. In a sequence, if there are 2 ideas you are trying to teach, then there will be 2 explore, explain cycles within the lesson plan. The one that we're going to show you today, sequence 1 from our unit, is just 5 lesson plans. It only has 1 explore, explain, but sequence 4 and sequence 5 in our lesson plan has that double explore, explain cycle. So that's important to know as we are working on figuring out this new way of teaching, what these different parts of the 5E lesson plan are. Each 5E lesson plan is its own sequence, and then all the sequences are put together to make the whole unit of To Space and Beyond. Next slide. So in the chat, I want you to think about the old Madeline Hunter that we learned about in college. I put the different parts on the side: input, model, guided practice, anticipatory set, and independent practice. Where do you think those line up with the 5E lesson plan? So go ahead and type in the chat. To go to the chat at the bottom, there will be a little button that looks like a cartoon bubble that says chat. You can click on that and then write down that if you think model goes with evaluate, then just write that down in the chat. I'm going to give you about 3 minutes to type in the chat. Yep, Jennifer, you got it. Anticipatory set does go with engage. What about the other parts to the 5E model? Where does that go with the traditional lesson plan? Good job, Felicia. Independent practice does match with explore. This is the awkward silence we have to get used to as we teach virtual classrooms. Because it takes a minute for people to type. Does anyone else want to take a stab at the other parts of the Madeline Hunter model? Okay, I'll put you out of your misery. Can you go to the next slide? Thanks. Okay, so the engage is anticipatory set, like Jennifer identified. Good job. The modeling that we used to do would be with the explore. Input is explain. The guided practice is elaborate. And independent practice is evaluate. So we model before we input, which is kind of backwards from the Madeline Hunter model. So when you're doing that, it might feel wrong or backwards. We're used to doing the input and then having students model and then doing the guided practice, but it's flipped. So that's an important part that we acknowledge and realize that this is not a traditional way of teaching. All right, the next slide.
Okay, so giving you an overview of our unit, we have 5 lessons. The first one is about moon phases. The second one covers tides. The third one covers eclipses. The fourth one covers the properties of the planet, and the fifth one is the students actually learning about and making their own model of the solar system. And each one of those has the 5 E's in it. So there's 25 total E's, but each one has 5, and they follow the exact same format that Mandy just went over with you. So what we started with was, you can see this Earth and Space model tracker over here, graphic organizer. And we have the students start with drawing their understanding of everything that they're going to learn in our entire space unit with these 5 lessons. So they will draw what they know about moon phases, what they know about tides, what they know about eclipses, and what they know about the properties of the planet. And then in the middle, they draw what they know about the solar system at this point. We do understand that this is probably not, actually I'd be surprised if it was accurate. It's most likely going to be very, very wrong. And that's okay, because as we teach them, they're going to change their thinking, and that's what scientists do. So that's what we want them to do as they go through it. So they would fill out the entire form on all 5 lessons first, and then at the very end of the entire unit, at the end of each unit, they can fill out each section so that you can use that as an assessment piece as you're going through and teaching it. So our first sequence is the engage, and the point of that is that you have a short activity to get them curious and to figure out what they already know. You're actually using this as a step to learn what their knowledge is. We're supposed to be also using it to figure out what their misconceptions are. We put common misconceptions up there. I already went over that in the beginning, but know that they could have misconceptions that we didn't list there as well. So it's really important as a teacher that you are watching what they're doing, because they could come up with something really wild. We have no idea what their knowledge is, and we really want to address any misconceptions that they do come into this with. And then we're engaging with the anchor and investigative phenomenon. So you can see on this slide, I told you that we listed the resources. So there's all the resources that we used, and it tells you what the engage step is. There's 3 columns with each step. This one tells you what the teacher is doing. This column tells you what the student is doing. And over here, you can see the anchor phenomenon, the investigative phenomenon, the guiding question, and the conceptual storyline that you're using as you're teaching this to the students. So moving to the next one, you can see, first you're handing out the graphic organizer that I just went over, and they're filling everything out. With this, we are actually sharing the guiding question. I know a lot of us have been taught, and our administrators expect us to put a topic and a do up on the board, but we're trying to get away from that, because we want the children to investigate, and we want the children to come up with these things on their own. So we're just putting questions up now. And the state is trying to help administrators understand that. So that may be a conversation that you need to have. But our guiding question is, how does the appearance of an object change based on the position of the light source? So our activity is not even addressing the moon. It's just giving the kids little objects and flashlights and letting them kind of play with it and figure out how does the light and where it's coming from, what kind of shadows does that cast for, so the students can kind of just play with that and figure out what that looks like. The anchor phenomenon is Earth's moon phases. That's our anchor phenomenon for a good portion of our unit because we want them to understand the shadows. But for this one, their investigative phenomenon is just what kind of shadows is cast when you shine the light on an object from different angles. So then,
Go ahead.
okay, so we actually have a video here of a rapid fire moon phases so that the kids can see it actually happening, and that's how they see the investigative phenomenon. And we actually asked them, in this case, how does the appearance of the moon change? And throughout our unit, you will see the ideal student response right here, because we want you to kind of see what the kids are supposed to get to. You're not giving them that response, though. Please understand that. They are getting there by themselves. It's just we wanted you to know kind of where you're going with that, but the kids need to figure that out, not you just tell them. If you read it to them, it really kind of kills the enthusiasm as well as the science and engineering practices that they're supposed to be learning. And so we don't want to give them any answers, but we are helping you as teachers. There's the answer. And then throughout the unit, we also have a model tracker right here. And this is really powerful and important to use because the kids in the first blocks up there, they draw their initial thinking. So what do they think about moon phases right now? And then they explain their thinking. So they're doing the model, which is in our standard, but they're also explaining what they think, like why they did the model that way. And then as we continue teaching, as we do next the explore step, they're going to come back to this and they're going to decide, I don't know if you can see it, but it says revise it, let me see, refine it, abandon it, or create it. And so as we teach the next step, they need to come back to their model tracker and decide what they're going to do with the model that they did up here. Because if it's completely wrong, they can abandon it and do a new one. But then they have to explain why, because we don't want kids just abandoning it just because it's easy and they don't want to go back and try to refine or change what they did, because that makes them think more. And the whole point of this is we want them to use their scientific practices and their engineering practices so that they can figure out how to do this on their own. So as we go through each thing, you'll be able to have the kids change their thinking and explain why they did that. And hopefully at the end of this, you'll have an accurate model of the moon phases, and it shows the children's understanding. Any misconceptions that they had will be corrected. So it's really important that you're looking at what the children are doing on the worksheet as they're doing it. This isn't a give it to them and don't check back again till the end when you collect it to see. We really need to be monitoring as they go through it so that we can correct any incorrect thinking. Okay.
So after you do engage, then the next step is explore, where you are going to give the students a common activity or experience. So then they are creating their own vocabulary. You are not teaching the vocabulary at this point. Whatever the students decide in their group to call it is what it's called. The students are making their own meaning for things. Again, you'll see the 3 columns, just like Sandy showed you in the other one. And they'll also be using their incremental model tracker. Now, the shared experience that we are giving them, if you'll go to the next slide, is we're having them, like is in this little video, they are going to be putting a styrofoam ball on a popsicle stick with one light in the room. And then they'll put it, their head is the earth, and then they'll go around and they'll see how the light changes on the moon from the Earth's perspective when they're holding it. If they're not holding it, then they have like a satellite view, and they're able to see that half of the moon is lit at all times. Those are 2 important concepts that we want them to use. There's a couple of tips. Make sure you cover the emergency light with black paper. I tried to do this in my classroom with the emergency light not covered, and we couldn't see any shadows. So that's pro tip number 1. For distance learning, you could have them use a pantry or a closet or a bathroom. You could have them use any sphere like an orange or a baseball. Do not use the word shadow with your students because then they get confused on what a shadow is. You want to focus on the lit side of the ball. So keep saying the lit side. How much of it is lit up? With partners, you'll see the Earth view and the space view. You want them to draw both models on their model tracker. If you can, if you are at school, you want to pre-stick the styrofoam. Megan, can you unmute your? Thank you. All right, Sandy, can you, as we do this, I want you to think about what an explore phase is. And I thought, oh, we could just show them the video. Would that be a good explore option for students at home during this at-home learning time? So go ahead and show the video. Be thinking, are they defining vocabulary for students? Are they explaining what's happened? Because that's not what we do during explore. See if it works. It goes with a book. Oh, okay, pause it for a second. You might have to. So she's explaining what the video or what the object is. I think you're on mute, maybe? No.
Sandy's not on mute, but if you do closed caption for the YouTube, it might work.
Do you want it on mute or do you want it off?
I want it on unmute.
So you want them to hear it?
Yeah. But you might need to close caption it at the bottom, the CC, then you'll be able to see what she's saying. Okay, so this gives you a good visual on what's happening, but she's naming the phases. So give me a thumbs up in the chat if that's good for explore or a thumbs down if that's bad for explore.
I'm going to mute it since they can see it so you can talk and they can hear you.
Okay, you can probably stop the video. Okay. All right, so in the chat, give me a thumbs up if you think that was good for explore or a thumbs down if it was not good for explore. And then why? Okay, I think we're at a consensus that it's not a good explore video. But why would it not be good? Who's coming up with the vocabulary for the moon phases? The teacher. She was the one saying the gibbous moon, the crescent moon. Those are the vocabulary that students should be using if they know them. If they don't know them, then as a team, they're going to say a fingernail moon. More than half of the moon is lit. Exactly. It gives this answers instead of letting students develop the ideas themselves. The activity itself is great, but at this point, we want them to come up with their own meaning and their own explanations, and she's explaining it in the video. Next slide.
Okay, so this is the explain. This is where you introduce the vocabulary, not the prior step. And then we also are supposed to be guiding the students to a deeper understanding and giving them an opportunity to demonstrate their conceptual knowledge. So here we are going through the phases of the moon and what causes them. We're going to talk about the waxing, waning, crescent, gibbous, all the vocabulary terms. I have the video here that I'm going to show you. Videos aren't just bad, but let's see, I'm going to jump. As he goes through this, you can see he starts to talk about, let's see if I can get it there. He does show him the different phases, and he is explaining what causes each one of those phases of the moon. So they really are getting taught, and they're seeing the vocabulary and what causes each phase, which is what we want them to do at this point. This is exactly what we're supposed to do. However, when you're done, you want to have a discussion with the students, and you don't want to skip the discussion, because we're not just throwing information at them that we want them to regurgitate. We want them to talk about these things. We want them to talk about why it's a waxing and waning moon, what caused those things. Would we see it? Where would we see that? Would we see the same thing if we're in America as if we're standing on the South Pole? We want those conversations to happen with kids because they need to be able to apply that knowledge to really any phenomenon. I mean, there's not a lot of phenomenons that go with moon phases, because it's not like you have a moon phase with a car or with anything else, but in space, all the moons are going to have moon phases. So we want them to be able to apply that, and we're going to do that in some future steps, but they really have to understand the patterns and the cause and effects to be able to apply it to a different phenomenon.
So in Explore, they come up with their own vocabulary and explain, you say, okay, you called it this, scientists call it this, but then they already have ownership of the concept before they learn the vocabulary, which is kind of backwards of what we normally do. So that's an important shift that we're making.
But it's also going to help it make more sense to kids, because now they have their foundational knowledge. We're just teaching them another term for it. And so it helps with ownership of their knowledge. So then in the Explain, we were going to show them a lunar calendar and ask them the question, will people in India see a full moon when we see a full moon? Because that really makes kids think, wait, if I'm standing in a different place, would I see the same thing? They really have to think about what causes moon phases to be able to answer that question. And the discussion is really rich in teaching them those things. So we have this presented as a debate. The kids, basically, you can have them decide, like divide them in half. Have half of the kids, well, they get to decide. Have the kids who think that they would see the same thing in India go to one side of the room, and have the kids that think they wouldn't see the same thing in India go to the other side of the room. And then they can try to convince each other of why they're right. And make it open so the kids can change sides depending on, well, maybe somebody made an argument that they really agree with, and now their mind has been changed, so they can switch sides. Because this way the kids are really communicating their ideas, they're asking questions, and they're really thinking, and that way they can apply their knowledge and they can convince each other. So they might have new concepts introduced that they hadn't thought of before. And it's just a really great opportunity for them as students to learn and communicate, but also for you as a teacher to see if there's any remaining misconceptions or anything that maybe they didn't understand as you were teaching, because then you can really help teach those concepts to them. So from Explain, we move on to Elaborate.
One thing that when my kids were trying to do that Explain debate, they were like, can we use the model? And I was like, of course you can use the model. So they got out the moon again and we're putting it around the earth and saying, see, it takes more than 24 hours for it to go around the earth, so it will be the same. And that was so powerful for them to be able to use that model to convince the rest of the class. So make sure you don't put away those moon sticks after the Explore stage. They'll use them again. The next stage is Elaborate. And in this one, we want to challenge their understanding because they think they know everything to know about moon phases. So we're going to show them an analogous phenomena. It's the same concept, but it's in a different context. So this emphasizes the cross-cutting concept. We are looking for patterns in the cross-cutting concept that we are reinforcing, and cause and effect. So it's really tiny, but if you look down there, you'll see a picture of Jupiter and its moon. And are there phases on those moons? And kids are like, whoa, mind blown, that there's phases of the moon on any round object. And so this helps them extend that pattern beyond just just our own moon. Again, it has the link to the picture right there, and then it has some guiding questions for you to ask. The next slide. And then it has some more extensions, some more pictures. You could even have the first picture taken of the Earth from the moon. Whoa, the Earth is in a phase 2. It's amazing. Every object in the solar system goes through phases if it's round. So that's the overarching concept we want them to learn. And it's all based on the position between the light of the sun and that round object. Okay, the next slide.
So then once we've gone through that, our last step is evaluate. And for evaluate, it's an analogous phenomenon. So it's not what we've already taught them, it's applying it to something else. So we've already taught them the phases of the moon from Earth. And then we talk about the phases of the moon of Jupiter. So now we're standing on the Earth and standing on the moon and talking about the phases that the kids will see with Earth. So we're applying it to something else that they have to think. When the state assessments are done, they are supposed to be what we hear. I mean, they're still being worked on, so we don't know for sure. But they're supposed to be applying this to something the kids have never seen before. So they could potentially create an imaginary planet, and the kids have to then decide what the phases of the moon will look like. And in this case, it won't change. It'll still be the same, even if it's some moon that they've never heard of before. We just want them to be able to apply that knowledge. So in this case, we're asking them, what patterns do you see in the picture? What patterns do you see? What patterns can you conclude from the picture? Does the pattern in the data support the conclusion that's caused by it? And you could even potentially do charts and graphs with them, because that could potentially be something that they need to be exposed to before the state assessment. So they can look at these and answer the questions for something they've never seen. And I know it's totally against everything we've ever learned. You don't just throw something they've never seen at them before when you're evaluating them, except now we do, because we want them to be able to apply that knowledge to something they've never seen before. So we really do need to make sure that we're practicing with things that they've never seen before, because we want them to be able to apply the knowledge. And that's how we see, did they understand the knowledge enough to apply it to something literally that they've never seen before. And then we go back to, we have our model tracker. So they are now now that you've taught everything, they're drawing their final model, because that's our standard. They actually have to be able to develop and use a model. So they'll do that on the model tracker. And then they will also go back, we're gonna give them a new graphic organizer so that they can draw here what their final model is of moon phases. And then they can write a little explanation here on the line. Really, depending on how you do grades at your particular location, you could grade this now as something in the grade book. You can wait till the end of the unit after you've covered tides, eclipses, the solar system, all of those things. So that's kind of up to you. We don't really tell you when you have to pull the grade, but it gives you an idea both on the model tracker and the graphic organizer, so that you can really see, did they understand moon phases? Can they apply it? What issues are they having with their understanding? What do you as a teacher still need to step in and help them with? Again, we're not giving them answers, we're guiding them to answers so that they really own that knowledge and they make it their own. And then we added one more element to it. If you have to get a group of kids, because this is really, really tricky, but we asked them, so if they found like a new moon on Saturn, please make sure that they understand this is fictional, and it rotated around the poles, what would that do to the phases of the moon? Because they really have to think about what happens with the shadows and the cause and effect, and how would that change the patterns that they're seeing, because it would. And so this is something you wouldn't necessarily use it with everybody, but if you had gifted kids or kids who needed an extra challenge, this is an excellent step to throw in there to really make them think. It's pretty advanced, but for you and I both know we all have those kids that just need that extra push, and this is a great way for them to get that.
And as students get used to thinking in 3 dimensions, and as they come up through the ranks, that second evaluate piece is more closely tied to what an evaluation of the concept would really look like, because it's something they've never seen, it's a fictional scenario, but then you could really see when it would be a full moon, it would be like a quarter of that half that they would see. They would see a half moon the rest of the time, except for at the poles. And so it would really be a mental stretch, but you'd really be able to see how much they were understanding. And that's where we want the evaluation to go. They're not there yet. That's why we gave you 2 options for evaluate. The final piece is the assessment piece. We have the post-assessment paper that you fill out. Also, we came up with this, the 3 most common misconceptions about moon phases. And we had a student, so this assessment needs 3 things. It tests their misconceptions, it gives students choices, and then it reveals their thinking. So of the 3 that are there, these are the 3 most common misconceptions. We've had them draw model after model after model. By this point, they should be drawing the model correctly. We should have talked to them, help them correct it. So we didn't really feel like that would be a good assessment. But here they have 3 different choices, or 3 different models drawn by 3 different students, and they have to tell us how come the student was incorrect. And they would identify the 3 most common misconceptions. So they're choosing the work, they're evaluating another student's work, which they've done in their groups with their model tracker. So this isn't something new, but we're trying to reveal their student thinking there. The next slide. Finally, this is the unit timing. We identified how many lessons are in each sequence. So we've gone over the 5 lessons in the moon phases sequence. And then about how many hours we think it's going to take to teach it, we don't know. It kind of depends on your students how long it will take. But just kind of for planning purposes, this is what we think. Please give us your feedback because we would love to know. Sequence 5 does have, we said it would probably be about 15 hours because there's so many ratios you have to teach. If you were teaching it at the end of the year, it might not take 15 class hours. But if it's at the beginning of the year, it's going to be really intense for them to be able to do those comparisons between planets of distance and size. Next slide. Okay, so questions. Do you have any questions for us? We have Jamie and Kaylin were also on our writing team, and they're in this class with us. So Jamie and Kaylin, please jump in if you have any questions, or if you know the answers to any questions that people ask us. So you can unmute your microphone and ask questions, or you can type them in the chat, either one. I know it's like drinking from a fire hose. You might not know what questions you have. The tool 4 lesson plan with all of the sequences is already up on the ASTA website. So you can go there and print it off for your use for virtual learning this fall. Sandy, do you want to share that last screen? This is my email and Sandy's email. If you, there we go. Okay, if you have any questions, you can contact us there. Or if you have any student samples that you think are good examples or bad examples, we would love to see those. If you have suggestions for tweaks on the lesson plans, we would love to hear those as well. So there is a question from the text box. What area sequence do you feel will be the most challenging for students? The most challenging for teachers? Jamie, which one do you think will be most challenging?
I think the last one is probably going to be the most challenging because it has, or yeah, probably the last one because there's so much math incorporated into that piece. The other thing that I think in general that is challenging for teachers, that's been challenging for me as I've made the shift starting last year, is really helping students understand evidence and how to use evidence and come up with their reasoning, putting into words their why. They seem to really struggle with explaining what they're thinking. So this is a great practice. The model tracker is really good for that and getting students to put on paper what you want to see. And at the beginning, as you start using these lessons and you start using that format, it is going to take longer to get them to think for themselves and explain what they think. So be prepared for that, but it is really powerful to get them to use that. Another thing that we noticed is having them refer back and use their notes and connect to that is also really important.
Absolutely. Thank you, Jamie. Kaylin, do you agree that which one do you think will be hardest for teachers to do?
Can you guys hear me?
Yes.
Okay. I actually agree with Jamie. I think the fifth one's going to be the hardest just because of all the math. And like you said, if you do it at the beginning of the year, it's going to take longer unless you wait until the end to where they had that, those lessons already on how to do ratios and everything.
Mm-hmm. I feel like the first one might be hard for teachers too, just because they're used to being the ones that I'm used to telling them a vocabulary, I'm used to telling them what to, and then we practice and we model after I've already taught them. So if you haven't made that instructional shift yet, that first sequence might be a little terrifying for you. But you have to trust your students that they're going to get it, that it's going to be okay. Sandy, do you have anything to add about challenges?
I think it's a new way of doing things. This is not typically how we teach, but I think that it's very, very powerful. And I think it hands the fun back to the kids. It gives them ownership, but it also makes it a lot more fun. Science stinks when you're just learning vocabulary and regurgitating information on a test. And it's really not preparing them for the real world, because seriously, nobody has ever asked me for vocabulary for a scientific term, not ever. But I often have to explain to my kids why things work the way that they work. So it's really giving that piece back to the kids and giving them ownership of it. But it also makes it fun. They're going to love the new science. But as a teacher, it's a little intimidating. Your principal's not going to walk into a completely organized, quiet classroom. There's going to be a little bit of chaos, but it's productive chaos, but it's still chaos.
Yeah. And I think it also prepares them for being a citizen in today's world with science constantly changing with new discoveries. We can't memorize facts anymore. We have to be able to synthesize new information based on old information, and kind of like with that elaborate and evaluate phase when it's, oh, this is a new situation. How does what I already know apply in this new situation? These are the voters of the future, and we have to give them the skills to get there, to make those good decisions for science in the future. You're right, Sarah. The last sequence would be a great one to collaborate with the math teacher on, especially if you struggle with ratios and percentages. I team teach with a math teacher, and she is so excited because she usually doesn't get to proportions until after the AZ merit test. So she's like, oh, you could teach that unit first, and then it'll just breeze, they'll breeze by. And I'm like, oh, okay. This might be more complicated than I thought. So are there any more questions that anyone has? Final thoughts?
Awesome. I'm not seeing anything in the chat, ladies, but thank you so much. I want to thank Mandy and Sandy from Mesa for sharing their unit with us today. Knowing that our new science standards requires teachers to shift the way they teach, we appreciate your